Yes. Properties of alpha radiation. Or alpha particle. So what are the properties of what? Of alpha particle? So this alpha particle, their nuclear symbol is helium. We use helium to represent the word the alpha particle. And the alpha particle, they are positively what? They are positively charged. They have large what? Large mass. They can be deflected by magnetic field. Let's go. One, they are helium particle. They are helium what? Particle, that is E24. So we use what? Helium element to represent or to denote alpha what? Particle. So if you look at what? In this detection of what? Radiation, the alpha particle moves toward negative pole here, which is what? South bar. So the alpha particle, they are what? They are positively what? Charged. So alpha particle, it is positively what? Charged. So the charge of alpha particle is always positive. The next thing is what? It has a large mass compared to what? To other. And again, the alpha particle also have what? A little penetrating power. They have little penetrating power. Power. In terms of penetrating what? Power, this alpha particle have what? Little penetrating power. That's why it can be stopped by what? By paper. You can say what? They can be stopped by what? Paper. This alpha radiation, this penetration, you can be stopped by what? By paper. So in terms of what? Of penetrating power, the penetrating power of what? Of alpha is what? Is little. In fact, it's lower than what? Than that of beta. Because it has what? High mass. So it can also have what? High momentum. But it has a high what? Momentum. Due to the what? High mass it possesses. The momentum is mass times what? Times velocity. And the alpha particle also have what? It has high what? High velocity. And if the penetrating power is this, then in terms of wavelength, the alpha particle have long wavelength. That will be how many now? 7. And they also have high velocity. Yes. So they have high what? High velocity. So these are the what? The necessary properties of what? Of alpha particle. The nuclear symbol for alpha particle is helium. Alpha particles has what? Positively charged. They have little penetrating power and they can be stored by paper. They have high momentum. They have what? Long wave what? Wavelength. Let us look at the properties of beta. properties of what? Of beta particle. So if you are talking of what? Of beta particle, so nuclear particle or beta particle, its nuclear symbol for beta particle is 11 what? That symbol is 11 what? Electron, which is E 0 minus 1, or you can write beta 0 minus what? 1. This is the what? Symbol for what? Beta what? Beta particle. So where we use helium to represent what? Alpha particle, we use electron to represent what? Beta particle. And the alpha particle is positively charged because the beta is negatively charged. So beta, it is what? It is negatively what? Charged. And the next one for the beta particle is have what? Little penetrating power. Beta they have little penetrating power than alpha. Alpha what? Particle. And they can be stopped by aluminum block. Next one, they have small mass and its mass is mass less than mass of alpha particle. These are the prices of what? Of beta particles. I said it is its nuclear symbol is electron. We use electron to represent beta particle, which is E minus. It has a negatively what? Charge from Rutherford's experiment. They have little penetrating power. No, this place is supposed to be the have high penetrating power than alpha. They have high penetrating power. That's why we can stop them by what? By aluminum block. And they have small mass. Its mass is what? Is very what? Its mass is less than mass of what? Of alpha particle. Yes. And the next thing is what? Yes, I forgot one thing here. It can be deflected by magnetic field. Yes. It can be what? Deflected by electric field and magnetic what? Magnetic field. So when you place it in a what? In a magnetic bar, it will be what? Deflected. The same thing to this what? Alpha. Let me add it to alpha here. Alpha particle is also what? Is deflected. Is what? Deflected by magnetic field and electric what? Electric field. Yes. So that will be 6. I have 9 there. Yeah, little per power, stop by the power. It have what? It is at a little momentum. It has a what? A little momentum, and it has short wavelength, and it has short what? Short wavelength, and it also have what? High velocity. So these are the what? The properties of what? Of beta particles. The last one is properties of alpha particle. Properties of gamma. Sorry. Gamma. This gamma is not a particle, is a what? Is a ray. The symbol for gamma is what? Is this? Its first property is what? Gamma ray. Let me say they are electromagnetic radiation. It's an electromagnetic what? Radiation. And it have, yes, they have high penetrating power. Power than alpha and beta particle. So in terms of what? Of penetrating power, this alpha particle less than what? Beta, beta less than what? Gamma. This is what? The increase in what? In penetrating what? Power. So the next one is they have no charge. Therefore, they cannot what? They are not deflected by magnetic field and electric what? Field. Next one is they have negligible mass. Yes, they have negligible what? Negligible mass. So it also have negligible momentum. Mhm. Uh, that's what? How many? 6. So these are the words, and this it can be stopped by lead block. They have high penetrating power, so that they can be stopped by what? They can be stopped by lead what? Lead block. Where beta particle can be stopped by what? By aluminium. Alpha particle can be stopped by what? By paper. So these are the what? The properties of what? Of gamma ray. You may ask in your exam, that is what? List the properties or 5 properties of what? Of alpha particle, beta particle, and gamma ray. Just take what? Best 5 among what? Among these. So this particular experiment we have here is the one that is used for what? To detect the nature of what? Of radiation. Abi? But here we are talking about the what? The penetrating power of what? Of radiation. So for penetrating power of radiation, this is the what? The diagram, the experiment diagram for penetrating power of what? Of radiation. Assume this is the what? The nucleus of radioactive what? Elements. And let me see say what? This is what? What? Uranium. So this is the nucleus of what? Of uranium. If this uranium exhibits what? Spontaneous disintegration, so it's a natural radioactive what? Of elements. So for this now, when it is undergo this, it will be emit what? Radiation. This time around, we have this, and we also have what? This. We also have another radiation that is come out like this, and then we also have the third one, which is what? Going up like what? Like this. You will observe that there is no magnetic bar here. If you put magnetic bar, this particle and ray, they will what? They will deflect it, abi? But there is no what? Magnetic bar here. What do we have here is what? We have something that we can use to what? To stop them. For this side here, the first thing here, we place paper here. Let me say we have this is a paper with green what? Marker. So this green marker represents what? Say what? Paper. You will observe that when this ray gets into the what? To the paper, this green marker represents what we call what? Paper. So you can use what? I said it here that what? It can be stopped by what? By paper. So the ray, which is what? Stopped by what? By paper. The ray that can be stopped by what? By paper is called what? Alpha. It's called what? Alpha. So, but the remaining two rays, they penetrate the what? The paper. And we use another one called this aluminium foil. If we place aluminium foil here, we observe that what? This aluminium foil stop what? Beta. So the beta penetrates paper and is stopped by what? Aluminium what? Stopped by aluminium foil. So here we have what? Beta. And the ray or the radioactive radiation that is penetrates paper and it also penetrates what? Aluminium foil. Aluminium foil. This third one penetrates aluminium what? Aluminium foil. And the only thing that we can use to what? To stop it is what? It's red is a lead what? Lead block. This is what? Lead what? Lead block. We have lead what? Block. So the only radiation which stopped by the what? By lead block is called what? Gamma ray. So this is the penetrating power of what? Of radioactive radiation. The alpha particles stored by what? By paper. Beta particles stored by aluminium. Gamma particles stored by what? By lead block. So you can see that what? This is the penetrating power of what? Of radioactive what? Radiation. We can say that what? In terms of penetrating power, this gamma is greater than what? Beta. Beta is greater than what? Alpha. This is what? Increase in what? Increase in penetrating what? Penetrating power. Or can do it in this form that alpha less than beta, beta less than what? Gamma. Like this, it will be the what? Increase in what? Increase in what? Penetrating power. Power. So for this radioactivity, this first experiment is the one that is show us the what? The penetrating power of what? Of radioactive radiation. This one is the one that tells us the what? The deflecting power or the nature of what? Of radioactive what? Of radiation. So this is what the two experiments. And the next thing is what? Let us talk about what? Detection of what? Of radioactive what? Radiation. So how are we going to what? To detect the presence of what? Of radiation. So we have like 3 to 4 or 5 devices that we can use to what? To detect the presence of radioactive radiation. We have by using what? The Gama tube, by using semiconductor plates, by using the diffusion cloud chambers. So let me just lead this detection of what? Of radiation. The what? Detection of radioactive radiation. Or let me just call it the detection of radiation. Radiation. So the radioactive radiation can be detected or detected in what? In laboratory by the following what? Device. The first one we have gigamolar tube. Yes, and an extra chamber. Number one, we have what? Gigawatt molar tube. Number two, we have ionization chamber. The number three, we have scintillation detector. Number four, we have semiconductor detector. Number five, we have solid state detector. Number six, we have diffusion cloud chamber. Let me put one more photographic plate. So these are the devices that we can use to detect the presence of what? Of radioactive what? Of radiation. So the Gamola tube, annihilation chamber, scientific distillator, semiconductor detector, solid plate detector, diffusion cloud chambers, and photoelectric plates. And the scope of all these devices is beyond what? This level. So we can explain the scenario that is happening in each device, how they will tell us what the presence of what? Of radioactive what? Radiation. So we are done about the what? The radio activities. So let me say, no, I said from the beginning that nuclear chemistry is study of nuclear reaction. Nuclear reaction comprises of radioactivities, radioactive decay, nuclear fusion, and nuclear fission. There are four processes. We are still on the radioactivities. So these radioactivity, these are the properties of what? Of radiation, and how we detect the penetrating power, and how we detect the nature or the kind of of particle that is formed from radioactive nucleus. So the next thing is what? Let us look at what are the properties of of nucleus of radioactive elements. So by looking at that, we need to check what we call atomic number, mass number, isotope, isobar, and isotope. So after that, we will now move to what we call from there we have what we call unstable isotope and a stable isotope. So why is it that what is not all elements we have in periodic table are radioactive elements? Some are radioactive elements where others are are not radioactive elements. What makes a radioactive element to be emit radiation? So that's what we are going to to treat. Now, let me rub the board.